Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session, we are going to discuss about carbon and its compounds from the class 10. Let us start now. So, introduction. Food, clothes, medicines, books, or many of the things that you listed are all based on the versatile element of the carbon. In addition, all living structures are carbon based. The amount of carbon present in the Earth's crust and the atmosphere quite minute. The Earth's crust has only 0.02% carbon in the form of minerals like carbonates, hydrogen carbonates, coal, and petroleum. And the atmosphere has 0.03% of the carbon dioxide. In spite of this, small amount of carbon available in the nature. Okay, and carbon compounds available in the many compounds, right? Like food, clothes, medicines, books, or all these things are made with carbon compounds only. Okay, and how much percentage of carbon is available in the earth crust? 0.02%. In the form of what? In the form of calcium carbonate. Sorry, in the form of carbonates. Carbonates are hydrogen carbonates in form of minerals. For example, here calcium carbonate, magnesium carbonate. Okay, so here carbon is there, right? This is a carbon, and magnesium. In this, we have the carbon is here, like that calcium hydrogen carbonate and magnesium hydrogen carbonate, sodium hydrogen carbonate, and you see this is the sodium hydrogen carbonate. Here carbon is there. Okay, and this carbon is present in the form of minerals, and this exists in the nature. How much it is? What is the percentage of carbon? It is exist in the earth crust, that is 0.02%. They exist in the form of minerals, and these are the salts of carbonates and hydrogen carbonates. Okay, and remaining 0.02%, 0.03% they exist in the atmosphere as carbon dioxide, and also it exists in coal and petroleum also. This carbon exists in coal and petroleum. So in spite of this, small amount of carbon available in nature also. Okay, now let us discuss about bonding in carbon, the covalent bond. Already you know that in previous chapter metals and non-metals we discussed about ionic compounds have low melting point and ionic compounds have high melting point and a high boiling point. So why ionic compounds have very high melting point and boiling point? Because they have the large force of attraction between the molecules. Whereas in case of covalent compounds, why the carbon compounds have low melting point and boiling point, and carbon compounds also we called as covalent compounds, and covalent compounds has low melting point and low boiling point. Why they have the low melting and low boiling point? Because the force of attraction between the molecules are not very strong. Because of this reason, the carbon compounds have very low melting point and a low boiling point. And one more question we have here: why carbon compounds are largely non-conductors of electricity? Because the bonding in carbon compounds does not give rise to any ions. Okay, so these are the covalent compounds. When you dissolve these covalent compounds in the water, they do not split into ions. Whereas in ionic compounds, let us say one ionic compound you consider here. So ionic compound example is NaCl. When you dissolve these NaCl in the water, these NaCl split into Na plus and Cl minus. So because of this, they conduct electricity. Whereas in case of CH4 or methane compounds, any covalent compound of carbon you take, they do not dissociate into ions. Because of this reason, they do not conduct electricity. Okay. Why carbon compounds have low melting point and low boiling point? What is the reason? They have very weak force of attraction between the molecules, or we can say that the force of attraction between the molecules are not very strong. Okay, this is for low melting point and low boiling point. And what is the reason of non-conductor of electricity? These carbon compounds does not give rise to any ions. Okay, move on to the next one. Next, this is about bonding in carbon and covalent compound. Okay, why carbon only form the covalent compound? Let us see now. So before going to discuss about why atoms forms with other atoms bonding and why they participate in the bonding with other atoms, let us discuss now. For example, every atom trying to get the nearest noble gas configuration. For example, when you consider the sodium, everyone please do it. When you consider the sodium has atomic number 11. Means in its valence, in its electron configuration, first two electrons present in the K shell, and the next 8 electrons present in the L shell, and the next one electron present in the M shell. So this is a K shell, L shell, M shell. Remember, every atom trying to get noble gas configuration, the nearest to noble gas configuration, or fulfilled configuration, or we can say that octet configuration. Compared with the octet configuration, sodium has one excess electron, right? So to get stability, sodium lose its one electron and form Na plus, and it lose one electron. After losing one electron, now you see it get octet configuration. This is a stable configuration, and after losing the electron, sodium got positive charge. Is it clear, everyone? Now when you consider the chlorine atomic number is 17. So first orbit consists 2 electrons, second orbit consists 8 electrons, and third orbit consists 7 electrons. To get 8 electron configuration, it requires one more electron. Then who will give this electron? Donated by sodium, and it will form Cl minus ion. This is chloride ion. Now you see this Cl will get now octet configuration in its last shell. Okay, so sodium has one excess electrons compared to the octet electron configuration. So when it sodium lose one electron, so it will get a stable configuration, 2-8 configuration, and chlorine also want to get 8 electron configuration. For that, one electron is deficient is there. So this electron is absorbed by the sodium, and it will form the stable configuration because of in opposite in charge in nature, and this Na plus and Cl minus, the force of attraction between these atoms are very strong. Why? Because they are oppositely charged. Opposite charges attract each other and form very strong compound, strong ionic compound. Because of force of attraction between these ions are very strong. Uh, for this reason, these compounds are having high melting point and high boiling point. Okay, so how the force of attraction will arise here? Because of this opposite in charge. Sodium is having plus charge and chlorine is having minus charge. Because of opposite in charge, it will form strong attraction force between strong attraction force arise between them. Because of that, it will form strong ionic bond. Okay, so in this way, to break this bond, we have to use high temperature, high melting point, and to evaporate this, we need more boiling point also. And these ionic compounds have high melting point and high boiling point. Whereas in the case of covalent compounds, they do not form like this. And how they form? Let us discuss now. When you consider the carbon, so carbon atomic number is, can you tell? Carbon atomic number is 6. What is its electron configuration? Carbon electron configuration is carbon electron configuration. Can you tell carbon electron configuration? First orbit consists 2, second orbit consists 4. Okay, remember this. That means the first orbit A shell consists 2 electrons and second orbit L shell consists 4 electrons. To get the 8 electron configuration, it requires 4 more electrons. Okay, or to get the nearest helium gas configuration, like 2 electron configuration, also fulfilled configuration, to get this configuration it has to lose 4 electrons, or to gain the 8 electron configuration it has to gain the 4 electron configuration. Means to get the 8 electron configuration it has to absorb 4 more electrons, or it has to lose 4 electrons to get the 2 electron configuration, like K shell configuration. Okay, now why this carbon do not lose the electron and they do not gain the electron? So why? Because now you see, if carbon gains the electron, so carbon has how many electrons? Can you tell? 6 electrons, 6 protons. If carbon, let us assume that if carbon gains the 4 electrons, if carbon gains 4 electrons, the electron number becomes 10, but proton number remains same. And remember, these 6 protons cannot hold these 10 electrons very effectively. For this reason, carbon cannot take these 4 electrons. Carbon cannot gain the 4 electrons. And one more thing is there, if carbon loses the 4 electrons, it will acquire the stable configuration of the neon. But why carbon do not lose the 4 electrons? Why? Because carbon has how many protons? 6 electrons and 6 protons. If you remove 4 electrons, means there are force of attraction from the proton, it is very strong. For this we have to use more energy. So for this we need very high energy. This is not possible. Why? Because these 6 protons hold these 6 electrons very strongly. Okay, do you want to remove the electrons from this? It is not possible. Why? Because these are force of attraction between the protons and electrons are more here. Okay. For this reason, we cannot remove the 4 electrons from the carbon. So for this, we require more energy. And this gaining and losing is not possible for the carbon. Then for overcome this problem, what the carbon will do? So carbon share the electrons. Yeah, carbon share these 4 electrons with other 4 electrons of other atom, and like this carbon form the covalent bond. For example, now you see, every time you remember, so which electrons participate in the bonding? Only last electrons, not inertial electrons. These 2 electrons do not participate in the bonding. Then which electrons participate in the bonding? And these 4 electrons participate in the bonding. Now remember here, all of you see here, look at here. So carbon has how many electrons? Last shell, how many electrons? 4 electrons. It has 4 electrons. Okay, it requires 4 more electrons to get octet configuration. Then who will give these 4 electrons? Hydrogen or any other atom you take. So suppose I am taking here hydrogen. Hydrogen atomic number is, yes, 1. It has only 1 electron. But hydrogen also require 1 more electron to get the helium configuration, 2 electron configuration. Okay. Then one more hydrogen will give 1 more electron, and say third hydrogen will give third electron, and fourth hydrogen will give 4 electrons. Like that. Now you see in the carbon atmosphere, we have how many electrons total in the carbon atmosphere? Total we have 8 electrons. Okay. And these electrons are shared by whom? Hydrogen electron. Like that it will form the bond with the hydrogen. Now you see, so this is a compound we called as methane. Now hydrogen also getting the stable configuration, carbon also getting stable configuration by sharing of electrons with these 4 electrons with the 4 hydrogen electrons. Yes or no? And now how we can represent this electron dot structure as a normal bonding form? So like this. This is CH4, or we can write as methane. Okay, so in this way the carbon share the electrons with other atoms and form the covalent bond. And these covalent compounds, listen carefully, these covalent compounds, they do not split into ions. And also there is no for the while compared with the ionic compounds, they do not have the force, strong attraction forces are very weak between the carbon and hydrogen. The force of attraction is very weak. That means they exist low melting point and low boiling point. For this reason, means the force of attraction between the carbon and hydrogen and this C2H is, they are very weak. It can very easily break. Okay, like you see the methane is the CNG gas, compressed natural gas, or petrol, diesel. Okay, for these compounds we do not require to evolve the heat. While when you keep these compounds in the during daytime or summertime, they will get evaporate easily. Why? Because they have very weak attraction forces between the atom to atom. Because of this reason, they have low melting point and low boiling point. And also these covalent compounds do not split into ions. For this reason, they do not conduct the electricity. And also we consider here covalent compounds are non-conductor in nature. Yes or no? Now this is about, yeah, bonding of carbon in the covalent bond. Okay. Yes. Now move on to the next one. Formation of covalent bonds. Okay. So what is covalent bond? How it will form? Because of sharing of electron. Because of transfer of electrons, ionic bonds are formed. Because of sharing of electrons, covalent bonds are formed. Now if you so if atoms share only one pair of electron, it will form only one single covalent bond. If atoms share the two pairs of electron, it will form the double bond. If atom shares the three pairs of electron, it will form the triple bond. Now example for single covalent bond, formation of single covalent bond in hydrogen atom. So before going to this, now you see what is the atomic number of hydrogen? Yes, hydrogen atomic number is 1. What is electron configuration? That is also 1. Yes or no? Electron configuration of the hydrogen is 1. And in first, this is the in K shell, it has only 1 electron. How many electrons we can fill in the first shell? 2 electron. 2 electron is the stable configuration. To get the stability, it requires 1 more electron. So how that one more electron will come? So let us say this hydrogen has one electron. So another hydrogen also has one electron. Okay, and these two hydrogens, how they will form the bond? So this hydrogen come closer to the other hydrogen and share these two electrons like this. Okay, now you see this hydrogen has now two electrons. Okay, other hydrogen also has two electrons, and here these two atoms shared only one pair of electrons. Because of this, they will form only one bond between them. Okay, this is example for the formation of single covalent bond. So let us discuss here. The atomic number of hydrogen is 1. Okay, everything is there now. Now you read this. Hence, hydrogen has how many electrons to fulfill the K shell? It requires one more electron in its K shell and requires one more electron to fill the K shell. So, two hydrogen atoms share their electrons to form a molecule hydrogen, that is H2. Okay, this allows each hydrogen atom to attain the electron configuration of nearest noble gas helium. If hydrogen gets two electrons, means it is a configuration of helium. So each hydrogen gains the two electron configuration by sharing of these two electrons between the two hydrogen atoms. Now you see hydrogen form the single bond here. Yes or no? Then these are the shared electrons. Because of these shared electrons, they form bond between the two hydrogen atoms. This is a single covalent bond, and also we can represent this H bond H is we can represent like this also. This we can write as H2. Okay, this we can write as H2, and this is for example for the formation of single covalent bond in hydrogen molecule. Yes or no? Yes, and is it clear everyone? Okay, now move on to the next one. Okay, now come to the chlorine. Let us say while going to chlorine, just now you see chlorine atomic number, just now we discussed chlorine atomic number is 17. That means the first orbit consists 2 electrons, second orbit consists 8 electron, and the last orbit consists 7 electron. Remember, only last orbit electrons only participate in the bonding, not inner electrons. Okay, to get 8 electron configuration, it requires how many electrons? One more electron. Yes or no? To get the 8 electron configuration, it requires one more electron. Is it clear? So now you see, while doing the electron dot structure, while drawing the electron dot structure, remember how many electrons you have to mention? These 7 electrons. Okay. So this is the first electron, second electron, third electron, fourth electron, fifth electron, sixth electron. Now this is the seventh electron. Okay, it's a single electron. Okay, so to get 8 electron configuration, it participates bonding with another chlorine atom. Let us say this is the first, second, third, fourth, fifth, sixth, seventh. Okay, and now you see this chlorine participate in the bonding with another chlorine atom like this. Okay, now you just these two electrons are shared by these two chlorine atoms and form bond like this. Okay, this is the electron dot structure of chlorine. Now, because of sharing of these two electrons, they will form one single covalent bond between the chlorine molecule. So this we can represent like this, or we can represent like this also, Cl2. Okay, in this way you have to draw the electron dot structure of chlorine molecule. Is it clear everyone? Okay, so next one. Next one, formation of double covalent bond in the oxygen molecule. So before going to that, so first you have to know the what is atomic number and what is electron configuration and how many electrons are required to form the bond. So that you have to know that. So how do you know this electron number? By seeing their electron configuration. What is the atomic number of the oxygen? Oxygen atomic number is 8. 8 means the first orbit consists 2 electrons and second orbit consists 6 electrons. To get 8 electron configuration, it requires how many electrons? 2 more electrons. Then what it will do? And this oxygen, now you see, this is the oxygen. This 6 electron only you have to represent here. Okay. So this is the first two electrons, and this is third, fourth, and these two electrons are lie in different shells. Okay, actual electron configuration is look like this. Do you know this? 1s2, 2s2, 2p4 means p subshell has p orbital has three subshells like this. Okay, so this is 1s2. Already you don't have this. For state government students, I am telling this. Now this 2p4, first electron, second electron, third electron, fourth electron. Now, when you observe this second orbit electron configuration, this is the first orbit, this is second orbit, L shell, and this is belongs to L shell, and this configuration 2s2 2p4 configuration belongs to L shell. This L shell, the electrons are filled in this manner. In the S subshell, the two electrons enters in the S subshell, and in the P subshell, the remaining how many electrons are there here? 4 electrons enters into the P subshell. Okay, to get the fulfilled configuration, it requires 2 more electrons, and these 2 electrons are unpaired electrons, they are not paired. You have to represent like this. Okay, and these 2 electrons are not paired, the remaining electrons are paired. Okay, to get a octet configuration or stable configuration, so what you have to do here, you take the another oxygen has 2 paired oxygen in the last shell. So these electrons only participate in the bonding, only second orbit electrons only participate in the bonding. Remember this, second orbit electron, these 6 electron again split into 2 2 1 1 like that. So 1 more electron is here and 1 more electron is here, and now you see these electron, yeah, it is coming closer to the another oxygen, and these 2 pairs of electrons shared by 2 oxygen atoms and form the stable compound like this. Okay, now you see in each atmosphere of oxygen, how many electrons are there? In green color oxygen atom, how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. In white color oxygen, how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. In this way, oxygen forms bond with another oxygen by sharing the 2 pairs of electron and form the 2 bonds. Then how it 2 bonds will form like this? O double bond O. Okay, and the remaining electrons need not to mention. Okay, so in this way the oxygen molecule form the double bond, or we can represent this oxygen this in this way, O2 molecule, oxygen molecule. So now you read this, so now you see formation of double covalent bond in the oxygen molecule. In the case of oxygen, we see the formation of double bond between the 2 oxygen atoms. This is because an atom of oxygen has how many electrons? 6 electrons in the L shell. The atomic number of oxygen is 8, and it requires how many electrons to get the 8 electron configuration? 2 more electrons. So it requires 2 electrons to complete this octet. So each atom of oxygen shares 2 electrons with another atom of oxygen to give the structure shown in this figure like this. Okay, and the 2 electrons contributed by each oxygen atom give rise to 2 shared pair of electrons. So this is said to be constitute a double bond between the 2 atoms. So in this way, we can see 2 bonds between the 2 oxygen atoms. Right? This is example for the formation of double covalent bond in oxygen molecule. Now here we have electron dot structure of ammonia. Before that, first we will discuss this formation of triple covalent bond in nitrogen molecule and how it will take place. Let us discuss now. Now you see, consider similarly in the same way, what is atomic number of nitrogen? Everyone please say, what is atomic number of the nitrogen? That is 7. Okay, so first orbit consists always, remember what first orbit consists always 2 electrons, and the remaining 5 electrons enters into the L shell or second orbit. And when you see the configuration of nitrogen, so in the first orbit it has 2 electrons in the S subshell. In the second orbit 2s2 2p3. Now to get a 8 electron configuration, here we have how many electrons now? 5, right? So to get 8 electron configuration, it requires how many electrons now? 3 more electrons. Okay, so it required 3 more electrons. Now configuration becomes like this, 2s2 2p3. Okay, so now you see the p subshell has how many electrons now? Only 3 electrons. It requires 3 more electrons to get the pair or to get the stable configuration. Then how do you represent these last electron configuration of nitrogen in the electron dot structure? Let us say you draw this nitrogen. Here how many pairs are there? Only 1 pair is there. So 1 pair you represent here. Okay, so here we have 3 electron pairs. 3 single electrons are there. You represent like this, 1, and 1 more electron you represent with this dot, and other 1 electrons you represent with another sign. So this is plus, means these 3 electrons you represent like this, otherwise you represent only with 1 sign. So with dot structures, just you maintain some space between the electron to electron. Okay, similarly you draw the another nitrogen atom. Okay, it is a paired electron, and these three are the single electrons, 1, 2, 3. So now what you have to do, this nitrogen atom coming closer to the another nitrogen atom and share these electrons with another nitrogen atom and form how many bonds here? 3 bonds. Like this, you draw the electron. This is a, yeah, around this green color nitrogen atmosphere. How many electrons are there now? You see, 1, 2, 3, 4, 5, 6, 7, 8. Around yellow color nitrogen also same. It has 8 electrons. Now in this way, this nitrogen forms. This nitrogen shares how many pairs of electrons? 3 pairs of electrons with another nitrogen atom and form triple bond between two nitrogen atoms, or we can represent like this, N2 molecule, and this is about N2 molecule. Okay, this is the formation of nitrogen. Now you read this. Nitrogen has atomic number is 7. And what is the electron configuration? First orbit consists 2, second orbit consists 5. To get the 8 electron configuration, it requires how many electrons? 3 more electrons. Then what it will do to get the 3 electrons? It share the 3 electrons with another nitrogen of 3 electrons and share the 3 pairs of the electron and form the triple bond between the 2 nitrogen atoms. So as this you have to write like this. In order to attain an octet, each nitrogen atom in a molecule of nitrogen contributes 3 electrons, giving rise to 3 shared pair of electrons. Okay, one nitrogen atom contributes how many electrons? 3 electrons. So this is said to constitute a triple bond between the two atoms. The electron dot structure of nitrogen and its triple bond can be depicted in given figure. So like this you have to represent. Is it clear everyone? Okay. So now come to the ammonia. Similarly, nitrogen forms another nitrogen with 3 bonds. Now there is no nitrogen, only we have hydrogen. Then how the one nitrogen can share how many electrons with the hydrogen? Let us discuss this. Now you see, everyone please. So what is the nitrogen atomic number? Nitrogen atomic number is 7. First orbit consists 2 electrons, second orbit consists 5 electrons. And these 5 electrons, this in the K shell, and this is the L shell. K shell electron configuration is 1s2, and this is the K shell electron configuration, and L shell configuration is 2s2, 2p3. This is a L shell configuration. Only last orbit electrons only participate in the bonding, right? So now this nitrogen requires how many electrons? 3 more electrons. Now it is hydrogen is there. There is no nitrogen now. Another nitrogen is not there, but hydrogens are there. But one hydrogen gives how many electrons? Only one electron. But nitrogen requires how many electrons? 3 more electrons, right? Nitrogen requires how many electrons total? 3 more electrons. What it requires? 3 hydrogen atoms. Means that it forms bonds with 3 more nitrogen atoms like this. Now you see, nitrogen has 1 electron pair, and these 3 are the unpaired electrons. Okay, nitrogen has how many electrons, and these electrons I am distributing like this. Just you distribute like this, these 3 electrons. Okay, nitrogen requires 3 more electrons. Then how it participates in bonding with the hydrogen? Now you tell hydrogen atomic number is 1 and it has only 1 electron in the K shell. To fulfill the K shell, it requires how many electrons? 1 more electron. So nitrogen requires 3 electrons. For this reason, it can bond with how many hydrogen atoms? 3 hydrogen atoms. Now you see, one hydrogen atom has 1 electron. Other hydrogen atom, second electron. And third hydrogen electron, this is the third hydrogen atom, gives third electron. Like that, in the nitrogen atmosphere, how many electrons are there now? You see here, 1, 2, 3, 4, 5, 6, 7, 8. But in a hydrogen atmosphere, you see, in hydrogen atmosphere, there are 2 electrons now. Here also 2 electrons. Here also 2 electrons. So in this way, here there is a formation of ammonia molecule. Ammonia molecule formulation is, in nitrogen has 1 electron pair. This is a lone pair, non-bonded pair electron, and also we call it as non-bonding electron. Why? Because these electrons are not participating in the bonding. Only these yellow color electron only participate in the bonding with the hydrogen atoms. Okay, so this is a nitrogen participate bonding with other hydrogen like this in this way. Okay, this is for formation of ammonia molecule. Is it clear everyone? Okay,